Duterte is a ruler. A ruler has 12 inches. Therefore, Duterte has 12 inches. Logic. Commonly known as the science of reasoning. Yan ang babanatan natin ngayon. Ang basic concept ng logic can be attributed to Aristotle na namuhay noong 4th century BC, before Christ. He used words, sentences, and deduction to prove arguments using techniques na pag-aaralan natin dito sa video na to. About 100 years later, Euclid formalized geometry using deductive proofs. Itong parehong subject na to, kinukonsider na inevitable truths. Sa Tagalog, hindi may iwasang katotohanan ng universe revealed to rational people. Kaya lang, noong 19th century, medyo nare-reject na tong idea ng inevitable truths. Na-realize nila na ang deductive system, like Euclidean geometry, ay totoo lang base sa original assumption. Siyempre, kung papalitan nga naman ang original assumption, new deductive system can be created. Kaya nga may non-Euclidean geometry. Eventually, several people developed the use of symbols rather than words and sentences. Isa sa mga to ay si Leibniz at sinundan naman ni George Boole. Boole? Yes.
Will you please repeat it?
Boole. Si Sir Boole, isa sa mga naunang gumamit ng symbolic logic in mathematics, together with his friends Augustus de Morgan. Sina Leonhard Euler at John Venn use diagrams to represent logical statements and proofs. Anyway, symbolic logic was further developed by the following: Jevons, Peirce, Schroeder, Frege, Peano, Russell, Whitehead, Hilbert, and others. In this topic, we are concerned with a statement that is a declarative sentence that can objectively determined as true or false, but not both. Ito ay tatawagin nating proposition or statements. Ibig sabihin, pwedeng true, pwedeng false, pero hindi pwedeng trolls. I mean, hindi pwedeng true at false at the same time. Okay? Sa English language kasi, there are many types of sentences. Few of them are factual statements.
Did you know that I'm riding this horse backwards?
Commands.
Get that nasty shit out of my face!
Opinions.
Ikaw ang pinakamagandang lalaki sa balat ng lupa.
Questions.
Paano masabi?
Exclamations.
Help! Help! Help!
In the objective study of logic, we will use only factual statements or propositions. Ang hirap naman kasi mag-decide kung true or false ang get out of my face.
Ginagawa mo!
Generally, there are 5 connectives. These are the negation, conjunction, disjunction, conditional, and biconditional. Iisa-isayin natin to as we move along. Example, let P be the proposition, today is raining, and Q, the propositions, I will go to the CR. And R be the propositions, I will play basketball. Commonly, we use the lowercase letters like P, Q, R to represent a proposition. Tawag natin dito ay propositional variables, yung PQR. Instead of writing the word, if today is raining, then I will not go to the CR, we can just simply write this. P implies the arrow symbol for if-then o sa conditional, not Q. Or, I will go to the CR and play basketball, can be written as Q and R. Kapag may combination na tayo ng 2 or more propositions, ang tawag natin doon ay compound propositions. In addition, the grouping symbols we use in algebra, like parenthesis, bracket, and braces, ay gagamitin natin to deal with compound propositions. A truth table is a diagram in table form that is used to show when a compound proposition is true or false based on the truth values of the statements that make up that compound statement. This will allow us to analyze arguments objectively. Kung baga, it is all about deciding when a compound statement is or is not true, based not on the topic itself, but simply on the structure of the statement and the truth of the underlying components. Let us begin with the negation, denoted by this wavy line called tilde. A proposition P can either be true or false. Dalawa lang naman ang possible values nun. Thus, its negation can be put into table as F and P. Nga pala, pag nagnanegate tayo ng proposition, most of the time, it's better to use the word not, or it is not the case that, or it is false that, kaysa hanapin natin yung opposite word nito. Example, the word beautiful. Medyo subjective tong word na to. Depende kung sino yung nakakakita. Instead of saying ugly, we say not beautiful. Unless we're dealing with binary concepts. Like in math, we can categorize any whole number as even number or odd number. Siyempre, kung yung isang number ay hindi even number, matik, add na yun. Okay? Conjunction. We use the symbol, the uppercase lambda, parang caret, to represent a connective end. Let us consider two propositions, P and Q. We know that there are two possible values for P and Q, T or F. If we're going to combine these two propositions, there are four possibilities. Ito yun. T, 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 F, F, T, and FF. Customarily, inuunan natin yung sets of T followed by the Fs. Hati sila. Kagaya ng nakikita nyo rito. Connecting P and Q by end, ito yung truth values nila. Example, sabi nung hindi namang kayabangan naming kapitbahay, I bought a brand new car and a brand new house. We can say that my neighbor is telling the truth if he or she bought these two items. By the way, the proposition can be written as, if we let P be the proposition, I bought a brand new car, and Q be the proposition, I bought a brand new house, I both true, hindi siya sinungaling. Hindi rin siya mayabang. Otherwise, kung isa sa mga to ay hindi niya nabili, sinungaling siya. Sinungaling. The compound proposition, P and Q, is false. Madali lang naman tandaan to. Kung ang connective mo ay end at may isang false doon, kahit ano pa ang kasama niya, matik, ang buong compound propositions ay false. Kagaya nito. Disjunction. We use the V symbol for the connective OR. At ito yung truth tables natin para sa OR. Kung babalikan natin yung humble kong kapitbahay, and yung statement niya is changed to, I bought a brand new car or a brand new house, where P is I bought a brand new car, and Q, I bought a brand new house. We know that he or she is telling the truth if one of these item is both. Kasi nga or, parang either. Kung wala siyang binili sa mga to, matic false na yun. Sinungaling. Ngayon, usapan natin itong both true. Actually, there are two interpretations of the word or. One is inclusive or, and the other is exclusive or. Sa inclusive or, may possibility na both statements, P and Q, are both true. Pero sa exclusive or, isa lang sa dalawa. Example, I will go to Manila or I will stay at home. Yung or dito may be interpreted as exclusive or. Kasi, one of the event may occur, but not both. Kumbaga, isa lang sa dalawa. Huwag mong pagsabayin. Pero dito sa compound propositions na to, you can buy a brand new cellphone if your mom gave you 10,000 pesos or your dad gave you 10,000 pesos. In this scenario, we may consider both. Kasi makakabili ka pa rin naman ng brand new cellphone kung pareho silang magbibigay. Yung or dito may be interpreted as inclusive or. In the study of logic, we'll use the inclusive or. Thus, yung statement natin kanina, ng humble na kapitbahay na I bought a brand new house and a brand new car is true if both propositions are true. Generally, in a compound propositions with or connective, if one proposition is true, you may conclude that the entire proposition is true. Kaya nga sa bangko, kung mag-apply kayo ng joint account, you will be asked by the teller or the manager if and or ang gagamitin yung joint account. Example, yung mag-best friend na si Bets at si Dogs nag-apply ng joint account. At end, ang pinili nila. Dito, hindi pwede mag-withdraw si Bets nang wala si Dogs. Kahawa mo sa sarili. Walang withdrawal na Pero kung or, ang pinili nila, pwedeng mag-withdraw kahit sino sa kanila. Pwedeng may sarili. Lalo na kung dalawa silang mag-withdraw. Pwede. A conditional statement, sometimes called implication, consists of two simple statements using the connective if, then. We use this symbol aligned with a single arrow pointing to the right to represent this connective. For the compound propositions P and Q, we write P, the arrow, Q. Or we can read that as P implies Q. Or if P, then Q. Where P is called the antecedent, sometimes hypothesis, sometimes premise, while Q is called consequence, or conclusion. The truth table for conditional statement is this one. Ngayon pag-usapan natin kung bakit ganito to. Let us consider what might be called the parable of the satisfied customer. Ipagpalagay nating labaday at bumili ka ng detergent, itago na lang natin sa pangalang tired. After hearing the advertisement which said, if you use tired, then your wash will be white. Sa anong sitwasyon pwedeng magreklamo tong si customer kay manufacturer? Tingnan natin. Sa una, sa P, gumamit ka ng tired, true. Pumuti ang damit mo, true. So, ibig sabihin, the advertisement is true. Pangalawa, true. Bumili ka ng tired. Q, hindi pumuti ang damit mo. The advertisement is false. Pwede ka magreklamo. Yan. Paso yan. So, tayo ngayon sa kombinasyon ng hindi ka bumili ng tired, pero pumuti ang damit mo. Alam natin na hindi false yung advertisement. On the first place kasi hindi ka naman bumili. Walang na-break na promise. So, kung hindi false yung statement, true na yon. Dalawa lang naman kasi pagpipilian natin, true or false. And the last combination, hindi ka bumili ng tired, hindi pumuti yung damit mo, same explanation. Hindi mo naman siya ginamit at hindi pumuti yung damit mo, wala kang karapatang magreklamo. Manufacturer, it doesn't break any promises. So, kung hindi siya false, true. In a nutshell, pwede lang tayo magreklamo if gumamit ka ng tired at hindi pumuti yung damit mo. We can also write that as P and not Q. Meaning, yung P and not Q should be logically equivalent to the negation of P implies Q. Pag sinabi nating logically equivalent, this happens if and only if they have the same truth values for all possible combinations of truth values for the simple statement that compose them. Maya, pag-aralan natin kung paano mag-construct ng truth table. Anyway, just to show, ganito kakalabasan naman. In addition, these are the commonly used alternative words for if P then Q, connective. Alam niyo naman sa English language. Furthermore, we called Q implies P as the converse of P implies Q. And take note that P implies Q is not logically equivalent to Q implies P. Hindi to katulad ng conjunction at disjunction. Yung and tsaka yung or, na P and Q is equals to Q and P. P or Q is the same as Q or P. Parang ganito. If today is raining, then the ground is wet. Does not necessarily mean that if the ground is wet, today is raining. Mamaya, iialang nilasing yung kaya basa. While not P implies not Q is called the inverse of P implies Q. And again, they are not logically equivalent. P implies Q is not equal to not P implies not Q. Pero, ang not Q implies not P, yung tinatawag nating contrapositive of P implies Q, are logically equivalent. P implies Q is logically equivalent to not Q implies not P. Ayan naman. Nagagamit ito sa math to prove ng mga theorem para mas mapadali. Example, prove that if x squared is an even number, then x is even. Mas madaling i-prove yan kung i-rephrase natin yung propositions to its equivalent contrapositive proposition. Pwede natin isulat to as, if x is odd, then x squared is odd. Pag sinabi natin odd, not even. Or not odd, even. Kasi dalawa lang naman ang kategorya niya. Pareho lang naman sila kasi P implies Q is logically equivalent to not Q implies not P. Contrapositive. The final connective, which we will consider, is the biconditional. If P, Q are two propositions, then the propositions P, if and only if Q, sometimes abbreviated as P, if Q, denoted by a line with arrowhead on two opposite ends, is called the biconditional. The truth table for this connective is, let us take this example. Assuming that proposition P is Mr. Khan, 69 years old. And proposition Q, Sir Khan was born 69 years ago. So, compound propositions na Mr. Khan P. Khan, 69 years old, if and only if he was born 69 years ago, is true if both P and Q are true. Siya ay 69 na, at pinanganak siya 69 years ago. Both true, so the entire proposition is true. Pero, siya ay 69 years old na, pero hindi naman pala siya pinanganak 69 years ago. False. Sinyan. Tapos sinabi niya naman, siya ay hindi 69, pero pinanganak siya 69 years ago. False pa rin. Pero kung hindi siya 69, si Mr. Khan P. Khan, hindi nga naman siya pinanganak 69 years ago. It makes the entire proposition true pa rin. Okay? Tandaan natin dito, ano? Take note. That P, if and only if Q, is logically equivalent to P implies Q and Q implies P. This suggests that there is a close connection between the conditional and the biconditional connective. On this table, it shows some other ways of expressing the P if and only if Q connective. To summarize, the truth table for these basic connectives are: in construction of truth table, take note that the number of rows or the number of possible combination of the variables involved is given by this formula. Number of rows is equals to 2 raised to n, where n represent the number of propositional variables. This formula can easily be checked by applying the fundamental principle of counting, o yung tinatawag natin na multiplication rule. Kasi every variable has two possible values, p or f. Anyway, ganito setup natin. Kung isa lang ang propositional variable natin, say p, 2 raised to 1 equals 2. Kaya yung number of rows natin, dalawa lang, p, f. Kung dalawa, pq, 2 raised to 2, which is 4, we have 4 rows. Ito yung pt, pf, ft, ff. Kung tatlo na sila, say pqr, 2 raised to 3 or 8, katulad ng nabanggit ko kanina, customarily, we start with the t's. 4 na t followed by 4 na f. tt, pt, ff, ff. Hooray! Then, tt, ff, tt, ff. Laging yung dulo niyan, tf, tf, tf. Alternate na sila. Ngayon, kapag ka-4 na yan, kaya na magtuloy. You will be expecting 2 raised to 4 or 16 rows. Mag-start ka ng 8 t followed by 8 f. Then, so on so forth. Let us try constructing a truth table for P implies not Q, close open parentheses, and R. At the start, we need to determine the number of rows. Katulad na banggit natin kanina, since we have 3 variables, ito na yung kakalabasan niya. Dito guys, sa P implies not Q, kailangan natin yung not Q. So, we just negate the Q. Kung true yan, gagawin natin false. Kung false yan, gagawin natin true. Giging FF, TT, FF, TT. Ngayon, yun na natin kunin ng P implies not Q. Alam natin na nagiging false lang to if the antecedent is true and the conclusion is false. Gumamit ka ng tired pero hindi pumuti yung damit mo. So, nagiging false lang siya kapag ka TF. Serving that, between these two column, we have the following result for P implies not Q. Finally, i-connect na natin siya kay R using the connective end. Alam natin sa end, kapag may isang false, false na lahat sila. Then, we have the following result. Note nga pala, tawag natin sa ganitong klaseng table with a combination of P and F values for the final result. We call that as contingency. Tautology naman, if a compound proposition that is always true no matter what the truth values of the propositions occur in it. Madalit salita, kung true lahat sila, tautology ang tawag natin doon. Pagka false naman sila lahat, ang tawag natin doon is contradiction. Or some author call this as self-contradiction. Try natin to another example. P and Q implies P. Since dalawa lang yung variable na involved, P at Q, so ganito na yung kakalabasan ng table natin. Kailangan natin dito si P and Q. So kunin muna natin si P and Q. We have P, F, F, F. Then, itong si P and Q implies P. Para hindi tayo malito kasi baliktad eh. Isulat natin dito si P para madaling tingnan. Lalabas na T, T is T. F, T is T. F, F is T. And F, F is T. So, etong example natin na to, no matter what the combination of P and Q, the final result is always T or true. Tautology. Try nyo itong example na to, contradiction naman ang lalabas dito. Meaning, false lahat. Balahat ako sa inyo. Another example, show that the negation of P or Q is logically equivalent to not P and not Q. Para mapakita natin na they are logically equivalent, we need to get the truth values of the negation of P or Q independent of the truth values of not P and not Q. Try muna natin tong si negation of P or Q. So, ito yung kakalabasan. Alam naman natin kapag or ang connective, pag may isang T, P na kaagad siya. So, inanegate natin to, ito yung kakalabasan. We have F, 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 T. Okay, ito na yung isang side. Tingnan naman natin yung isa. Kailangan natin dito, negation of P and negation of Q. F, F, T, T, then F, T, F, T. So, i-connect lang natin sila using the connective. So, F, F is F, F, T is F, T, F is F, and T, T is T. So, kung mapapansin nyo, they are equal. So, ibig sabihin, they are logically equivalent. Actually, ito yung tinatawag natin na De Morgan's law. Valid arguments. Arguments consist of the sequence of statements P sub 1, P sub 2, P sub 3, up to P sub n, called premises, followed by a final statement called the conclusion, Q. It can be written as P sub 1 and P sub 2 and ... hanggang P sub n implies Q. Pareho lang sila. By the way, itong tatlong dot na to, it's a symbol used for concluding word, not therefore. An argument is said to be valid if and only if this argument is a tautology. Ibig sabihin, true lahat. One way to determine the validity of an argument is by constructing a truth table. Generally, an argument is valid if the conclusion necessarily follows from the premises, and invalid if it is not valid. An error in reasoning that leads to an invalid argument is known as a fallacy. Ito yung argument in which The premises do not justify the conclusion as a matter of logic. Okay, let us consider this argument. If the answer in number 1 is true, then false is the answer in number 2. True is the answer in number 2. Therefore, false is the answer in number 1. We may let P be the proposition. The answer in number 1 is true. Siyempre, pagka ginawa mo false yan, negation of P. Proposition Q, false is the answer in number 2. Pag ginawa mo true yan, not na. Pag sinulat natin to into symbolic form, we can write this as P implies Q, not Q, therefore, not P. Or we can write this horizontally as, so we can verify this using the truth table. Siyempre dito, kailangan natin si P implies Q, kukunin natin siya. Kailangan natin si negation Q. Then, we connect this using the connective end. Ito na yung kakalabasan natin. Kailangan din natin si not P. Since na may value na tayo ni P implies Q and not Q, and meron na rin tayong not P, kukunin natin yung implication nila. Kung mapapansin nyo, lahat sila ay true. Ibig sabihin, this argument is valid. Okay? Another example, if I exercise every day, then I will lose weight. I don't exercise every day, therefore, I won't lose weight. Valid the argument natin. Tingnan natin. So, let P be the proposition, I exercise every day. Q, I will lose weight. Putting that into symbolic form, we can write that as P implies Q, not P, therefore, not Q. So, again, we can rewrite this as this one. No? Kailangan uli natin si P implies Q. Ito na siya. Kailangan din natin si not P. Negate natin si P. So, we have this, FFTT. Then, we can connect that using the end connective. And, we have this one. And itong buong value na to implies not Q. So, kailangan natin si not Q. Ito yung lalabas na sagot. Then, letting its implication, we have T, P, F, T. Oh, man. Invalid argument. Ibig sabihin, the argument is invalid. Sa bagay, di naman kailangan mag-exercise araw-araw para pumayat. Pwede naman gabi-gabi.
I owed him up.
Ito yung tinatawag natin na fallacy of inverse. Napakaraming fallacy. You can check the internet for that. Yung nabanggit natin kanina na unang-una regarding the statement Duterte is a ruler has 12 inches, and therefore, Duterte has 12 inches is one of the fallacy. For our previous examples, medyo carry pa ang truth table. Kasi konti pa lang ang mga variables na involved. Paano kung madami na? Like, good luck, diba? Kaya ang ginawa dito, logicians deduce the conclusions from their premises by a shorter, more elementary arguments that are already known to be valid. Itong table na to is commonly used for formal proof of validity. The table of inference and the table of the rules of replacement. Hindi naman ganun kadami. Pause nyo na lang itong video na to get a closer look for its content. Tira tayo ng isang example gamit to. Say, we have already dissected the arguments and put that into symbolic form. Ito na yung kinalabasan. P or Q quantity implies R implies S, not S, therefore, not Q. Let us check if this is valid. Ang style natin dito, we put these premises as given na kailangan, we will come up to the conclusion of not Q using the rules of inference and rules of replacement. Fourth step, we'll be having P or Q implies S. Saan galing to? Kung mapapansin nyo, I use hypothetical syllogism on the first and the second premise. Then, I will going to use modus tollens on premise 4 and 3. So, ang kakalabasan yan, the negation of P or Q. Next step natin, I can use the De Morgan's law from premise number 5. We'll come up with not P and not Q. Then, we can interchange the position of this. The reason behind is commutative law. And, finally, from 7, we can conclude not Q by simplification. Ibig sabihin, this argument is valid. Pwede nyo i-check to using the truth table. Good luck. Kasi there are 4 variables, P, Q, R, and S. So, bali 16 lahat yan. Mga kakaduling yan. Anyway, if you do that, you get a tautology. True siya sa lahat. So, valid. So, medyo matyaga-tyaga kayo, Manila paper, pakakalabasan niya. Medyo dinugo ang natin doon. In addition, some connectives like exclusive OR, negation of AND, denoted by NAND, and NOR, negation of OR sometimes XNOR, negation of exclusive OR, are commonly used in circuit application sa logic gates. And most of the time, they replace T by 1, F by 0. Parang on-off, on, 1, off, 0. Ganon din yung logic behind. The algebra behind simplification of this circuit is known as Boolean algebra. And these are the table. Sila lahat using the TF notation and using the 1-0 notation. Okay? Sana nakatulong tong video na to for your further understanding of the concept. Bibitawan ko nga pala sa inyo tong Abraham Lincoln once said that you can fool some of the people all of the time and all of the people some of the time. But you cannot fool all of the people all of the time. Thank you for watching, guys. If you have any questions, clarifications, comments, suggestions, message lang sa chat box. Maraming salamat nga pala sa mga naka-subscribe na at nanonood. Na sa mga hindi pa naka-subscribe, you know the logic behind. Thank you very much. Much too. Shoutout nga pala sa mga sumusuporta sa channel na to at sa mga Pinoy vloggers natin. Suportahan natin sila. Like.
Hello guys! Welcome back to my channel, Diary.